Hello, geometry students. Welcome to class today on Friday the 8th. Hope you guys have had a good week and hope you're looking forward to a better weekend. Let's see what's going on here with announcements very quickly. There will be a quiz next Wednesday, so please keep that in mind. On Tuesday, I will let you know more specifically what will be on that quiz. You do owe me yesterday's homework. Let me see if I have that handy. I'm not going to write it down. Yeah, I will write it down very quickly. It's page 276, numbers 5, 6, 10, 12, 5, 6, 10, 12, 16, 18, and 19. So you owe me this homework. Probably some of you turned it in yesterday. But if you did not, that is due now, so please turn your homework in, which leads me to my next comment. The reason I don't know if some of you turned it in is I did not make it to the school yesterday. That is my fault. I apologize. I'm usually very good about getting tests and quizzes back to you, and this will be one of these times where I just wasn't able to, just due to, large family and doing a lot of things, it wasn't time, so I do apologize. Because of that, Jason, because I did not stop by the school on Thursday afternoon to pick up papers, I don't know if you took your test or not. So what I had said is you must take your makeup test by Friday. Now, Mr. Harmon should have that copy, both parts, the fill in the blank and the math part. And then I told you if you did not want to take a makeup quiz, we would let this test count for a quiz and a test both. So I'm letting you make that decision. If there's any problems with this, just call me or email me, okay? earhartmichael@juno.com or 706-965-2675. By the way, one student out of 4 of you has yet to email me with your email address at my Juno account. So everybody's done that but one student, and you know who you are. I don't want to embarrass you, but please shoot me off an email. I got one today where one student said, hey, the new microphone sounds really good. Another student emailed me and said, hey, here's my email. So send me off an email at juno.com so I can record your email and have that in my records, okay? Thanks so much. And that's basically it for the announcements, okay? So grab your notebooks, pens, pencils, books, calculators, everything you need, and please give me your undivided attention. I don't think I'm super long-winded, and I will try not to be long-winded today. We are going to finish Chapter 5 today. It's the very last lesson in Chapter 5. At the beginning of the chapter, I told you students then that the chapter was about congruent triangles, and I don't think you would argue with me on that. We learned many ways to prove that triangles are congruent: side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse, leg. And so the chapter's been all about congruent triangles, like I told you it would be. We are going to end the chapter today with an easy lesson. So I'm very thankful it'll be easy for you. And I think if you'll listen well and take some really good notes, you will totally understand the lesson. And it's also a lesson that really doesn't, and I guess I should fix my apostrophe while I'm talking to you guys. It's also a lesson that really doesn't have a lot to do with congruent triangles. And textbooks sometimes do that. They will end a chapter with a lesson that they just kind of cram in at the end that maybe has a little bit to do with the chapter, not a whole lot, and that's what this lesson is about. It's important, but it really doesn't have a whole lot to do with congruent triangles, and sometimes textbooks do that. The heading today is Reflections and Symmetry. Reflections and Symmetry, lesson 5.7, and the date today is the 8th. If you'd like to keep track of that, I encourage you guys to write that down. Reflections and Symmetry, lesson 5.7, and the date today is 11/8. My throat's giving me a little problems tonight, so I apologize. I'll be clearing my throat a lot. Okay, reflections and symmetry. Let's get started, please. Write this in your notes. I will definitely quiz this on you next Wednesday. Okay? I will quiz you on this. A reflection is a transformation that creates a mirror image. A reflection is a transformation that creates a mirror image. Let me give you an example, please. Copy this example in your notes. Let's say that I have a line right here. And let's say on this side of the line, I have maybe a triangle that looks like this. Can you draw that, please? Now, pretend this line, let's pretend we have a big sheet of paper. Here's a sheet of paper, okay? And let's say this is the middle of the sheet of paper, right where this line is drawn. And let's say, now use your imagination, students, okay? Let's say you folded this piece of paper in half. So you took this end here and you brought it over and you touched this corner to this corner. And you brought over this corner to this corner. So basically you're folding the paper in half long ways. If we did that, wouldn't this triangle, the triangle would not look like this over here if we were to fold it in half. And let's say this triangle right here was made out of really thick ink, and so when you folded the piece of paper over and pressed down, that's not the triangle you would get. Come on, think about it, students. In fact, if you want to, go ahead and take a sheet of paper and do this. Go ahead and try this. Go ahead and draw a piece of paper, draw a triangle on a half a sheet of paper and fold it over long ways, and you're going to see this. When you would fold this over, the triangle would look like this over here. It would look like that. It would be reversed. It would be opposite. Because if you pick this up and you brought these corners over and touched right here and pushed down really hard, this triangle would look like this over here. It would be reversed. Let me show you with, let's say, a line. Okay, and by the way, if you don't see that, please take a second, pause the video, get out a sheet of paper, and draw a triangle like I just did, and then fold the piece of paper, and you'll see, you can look through the paper and see the triangle will be a reverse mirror image. Okay, let me give you another example. Let's say that you had a line drawn on this side of the paper that looked like this. Okay, a reflection of this line right here would not look like this over here at all. Think about it. If you took the paper and folded it over, the line, this point here would come way over here, and this point here would be right here. So the reflected line would look like this. It would be a reverse image. This is an example of what a reflection is. I hope you're seeing it okay. All right, and we say that this line here is reflected on this line here. Okay, let me say that again. We say that this, we'll say line M, we'll call this line A, and we're going to call this line B. You would say M is reflected on line A. Okay, this is the line that the reflection takes place. Okay, M is reflected on line A because that's the part that's being folded. Okay, and so that's what we're looking at today, is reflections like that. Let's go ahead and delve a little deeper, and I think as I do this it'll make more sense for you. You can copy this diagram in your book, or you can just write down page 282, example number 1. And whatever you choose to do, it would be very important that you pause the video and go ahead and turn to this page. You really need to be on page 282 because I'm going to read some things to you from this example. So we're on page 282, example number 1. I'm on page 282, example number 1, and here's the picture you see in your book right here. Now I want to look at about 3 or 4 questions they ask us, okay? Here's the first question. Is the image congruent to the original figure? Now congruent just simply means, are the two triangles identical? Everybody see that? And are these two triangles identical? Yes, they are. Now we're just going by the naked eye and just eyeballing it, but yes, they look congruent, so we're going to go ahead and say yes, they're congruent. Now look at question number 2. Is the orientation of the image reversed? Well, yes, it is, definitely. This triangle here is a reflection of the red triangle, or we can say the red triangle is a reflection of the blue triangle, definitely. If you were to take a piece of paper and fold it on this line here, fold the paper right in half right there, we would see this triangle here. This point right here would rotate and it would be right here. This point here would rotate and be right here, and this point here would rotate and be right here. And so this triangle here is a reflection of the blue triangle. And so I'm going to continue saying this over and over. I'm going to go ahead and say yes, red is a reflection of the blue triangle. I'm going to say this over and over. Again, if you could fold this piece of paper, if it was a piece of paper right here, a gray sheet of paper, and you could fold the paper in half on this long line here, this triangle here would fall right on top of that triangle there. Thus, they are reflections of each other. Now, I would like you to go ahead and make note in your books on this example here, page 283, example 2. Page 283, example number 2. Copy this in your notes, or just make reference that we're on this page, whatever you choose to do, but please look at the problem. Question number 1, if you'll look at the top of the page on page 283, question number 1 under example 2 says, is the image congruent to the original figure? Yes. This triangle here, to me, looks like an identical triangle to this. Now, we're not for sure, I guess. We're just kind of estimating it. But yes, those two triangles look congruent. So we're going to say yes. And now look at question number 2. Is the orientation of the image reversed? Or in other words, are these triangles reflections of each other? And the answer would be no. Come on, think about it, students. If I were to pretend this is a gray sheet of paper, if I were to fold the gray sheet of paper in half right there on that black line right there, this point here would end up, or should end up, way over here. And this point here would end up way over here. And this point here would end up right here. So the triangle that you would have would be one that looks like that. Now that black triangle right there is a reflection of the blue triangle, but this red triangle right here, the one that we have for the example, this is not a reflection of the blue triangle. Do you see the difference? If not, you might want to pause the video, and this might sound pretty immature, but I think you should do this. Get out a sheet of paper, draw an object like this triangle here, fold the paper exactly in half, and notice how the triangle will flop over, and it would look, the triangle that would appear would be a triangle like this. It's really important that you see that. Okay? Alright, let's continue on in your notes. Now you're welcome to copy this picture in your notes, or just make reference that we're looking at page 283, example 3. But I'd like us to look now at page 283, example number 3. Excuse me. Okay, question A. Follow along as I read the question, please. Which segment is the reflection of AB in the x-axis? Now let me help you see this. Are you ready? Let's read it again. Which segment is the reflection of AB? So here's AB. Here's AB. Which one of these two lines, is it this one right here, or is it this one right here? Which one of those two lines is the reflection of AB in the x-axis, or on the x-axis? Well, this is the x-axis. Remember what I told you earlier in the class period. If I say this line here is reflected on or in the x-axis, that means this is where you're folding the paper. Now you're really not folding a paper, but I'm just saying, for lack of a better expression, whenever it says AB is excuse me, reflected in the x-axis, that means if you were to fold the paper here, and that means this corner would rotate down to this corner here, and this corner here would rotate down to this corner here. If you were to do that, which one of these red lines would be a reflection of the blue line? This one right here would be. This one would be. Okay? Right here. JK. JK. Now, if you continue reading part A, we're not done with part A yet. Look at the book there. It says which point corresponds to A. Well, if you were to fold this piece of paper right here, point A would fall right on top of J. So what point corresponds with A? J does. And this point here would fall on top of this point here, which is point K. So what point corresponds with B? K does. So J sport corresponds with A, K corresponds with B. Now let's continue on and look at part B. Question number B, or question letter B. Which segment is the reflection of AB in the y-axis? So here's your y-axis right here. So pretend now we're folding the paper long way. So we're folding it right here. So this corner would come over and touch this corner, and this corner here would come over and touch this corner over here. Which red line would be the reflection of B? Well, it would be this one right here, because we're folding the paper in half right here. And obviously B would fall right on top of E, and A would fall right on top of D. So this line here is, we would say about this line, we say this segment is the reflection of AB in the y-axis. Let me say that again. This segment here is the reflection of AB in the y-axis. And we say in the y-axis because that's where you're quote-unquote folding the paper right there. So ED is the reflection of AB in the y-axis. Okay, then it goes on to say which point corresponds with A. Well, I already said A and D correspond together and B and E correspond together. This is really an important problem, and I picked this because I wanted you to see a lot of stuff. For example, I wanted you to understand what it means when it says reflected in the x-axis, or ditto marks here, reflected in the y-axis. That's basically telling you where the paper is being folded, if it's being folded. Let me grab a drink of water here real quick. Okay, so I hope that helps, and I hope that makes a little bit of sense to you. Now let's continue on. We're almost finished. I want you to write this note in your notes. You could very well be quizzed on this on Wednesday. When a reflection takes place, like there was some here and here, well, there wasn't one here, sorry, like here and here. When a reflection takes place, there is always a line of symmetry. When a reflection takes place, there is always a line of symmetry. Please write that in your notes. Really sorry about my throat, students. Now, write this in your notes if you would. A line of symmetry is a line of reflection. Please write that in your notes. That would make a great quiz question next Wednesday. A line of symmetry is a line of reflection. Now, let me explain what that means. Let's come back up here. Triangle B was reflected on M, okay? In other words, this is where we fold this sheet of paper right here. Well, you know what else this red line is called? It's called the line of symmetry. So now you're figuring this out. Whatever line a reflection is reflected on, in this case here we would say the blue triangle is reflected on line M. That means it rotates on line M. We can also call that line the line of symmetry. Same thing with this example here. When we looked at letter A and it said which segment is the reflection of AB in the x-axis, or folded on the x-axis. X-axis also could have been called your line of symmetry. When we're talking about this reflection right here, these two lines, this one and this one, well, now my line of reflection, or my line of symmetry, is this line right here, because that's where the paper would be folded if we were going to fold it. Okay, so we call that a line of symmetry. So it's very important you understand when a reflection takes place, there is always a line of symmetry, and also understand a line of symmetry is a line of reflection. Now you're probably going to laugh a little bit, and you'll see this one page over in your book. This guy's having a little too much fun. Actually, I think it's a photograph. They did one of those trick things to it. I think this is the same person here that's here, and I think they kind of split it up. But anyways, this would be an example of symmetry. We have symmetry. We have a reflection. If you were to fold this picture right down this red line right here, this hand here would fall right on top of this hand. This arm would fall right on top of this arm. This half of his face would fall on that half of his face. This leg would fall on this leg, etc., etc. You get the point, I hope. And so we would call that red line right here a line of symmetry. It's cutting the picture in half. It's a line of reflection. I hope that helps. I really do. Okay. All right. Here's your homework for tonight. We're going to do pages 286, numbers 8 through 16, and the same page, numbers 21 through 26. Of course, all of these. So 8 through 16, that's 7 problems. 21 through 26, that's 6 problems. So pretty small assignment, not too bad. 13 total problems. This will be due on Monday. Now, Haley, you're new to the class, so again, I'll be telling you little things. All homework gets turned into Mr. Harmon, your supervising teacher. Okay? If you finish this today in class, which happens quite often, feel free to give that to him. Just make sure your name is on it and make sure that you've completed all the problems. But if you don't, it's due Monday. And also, I want to remind you one more time, Haley, this will probably be the last time I'll do this. The video you want to look up is called, well, let's go back and look real quick just for you, okay? Remember, the lesson was called 5.7. 5.7. So what you would look up for help on this homework video would be Geometry 5.7, which is the name of the video you're watching now, but then I tack on the word homework. And if you'll look that video up on the web page there, you will see I have all these problems worked out for you. And again, all you students, not just Haley, but all you guys, listen, if you copy that and don't really know what you're doing, you're going to have a really good homework average and a really bad test or quiz average. That's not going to help you pass the class. So don't just copy it. Allow this to help you understand the math. Okay, hope you guys have a great weekend. I hope that you're doing well. Call me or email me if you have any questions at all. And Jason, do not forget about your makeup test and or quiz if you're going to take the quiz. And that's basically it. And if there's any problems with that, Jason, just call me or email me and let me know. Have a good weekend, guys.